How can you have an arid desert right next to the ocean? Today we are going to explore why coastal deserts exist, how to incorporate these types of deserts into your world, and what they mean for your world building. So first, why do arid coastal deserts exist? Arid coastal deserts are found on the western margins of continents, often in the subtropical zones, where the convergence of oceanic currents, coastal geography, and high-pressure atmospheric systems creates hyperdry conditions. Let's unpack that explanation by looking at 4 real-world examples of arid coastal desert regions. We turn first to the coastal deserts on the western side of South America. It's here that you'll find the Atacama Desert in the south, and the Sechura Desert to the northwest along the Peruvian coastline. Both deserts border the Pacific Ocean to the west and the Andes mountain range to the east. The main focus for our purposes will be the Atacama Desert to the south. Even though it is right next to the Pacific Ocean, the Atacama Desert is a hyper-arid coastal desert that is considered one of the driest places on Earth. There are 5 primary reasons for the Atacama's hyperaridity. First, Hadley cell circulation creates a strong subtropical pressure belt, which significantly reduces precipitation. Second, the Peru current, which is also known as the Humboldt current, carries cold water from the south up along the western coast of South America. This results in upwelling, where winds push warm surface waters away from the coast and cold, deeper waters rise up from the depths of the ocean. That upwelling results in temperature inversion, which traps moisture near sea level and significantly reduces precipitation on land. Third, to the extent there is moisture coming off of the Pacific Ocean, the high elevations of the Chilean coastal range reduce the amount of moisture that's reaching the Atacama Desert. Fourth, there's a continental effect reducing moisture, caused by the distance between the eastern edge of South America and the western Atacama Desert. Fifth and finally, what moisture does reach all the way across the continent from the east runs into the Andes Mountains, creating a significant and discernible rain shadow effect on the map. With those factors in mind, let's head across the ocean, almost directly east from the Atacama Desert, where we'll find the Namib Desert. The Namib Desert is located along over 1,000 miles of the Atlantic coast of Africa, along a narrow strip that goes between 30 and 100 miles wide. This story should start looking familiar. Just like the Atacama Desert, the Hadley cell circulation again plays a crucial role, and the desert lies under the influence of a subtropical high-pressure belt. Just like the Atacama, you have a cold ocean current, this time the Benguela current, flowing northward along the southwestern coast of Africa and bringing cold, nutrient-rich waters along the coast. Again, just like the Atacama, winds push the warm surface waters away from the coast, and those waters are replaced by those deep, cold waters from the Benguela current in that process of upwelling, which results in a temperature inversion. And just like the Atacama Desert, you have both a continental effect, where the moisture from the Indian Ocean does not reach the Namib Desert, and a rain shadow caused by mountain ranges to the east. This same story replays on the northwestern coast of Africa on the Saharan Atlantic coastal desert. Here once more, you have an arid coastal desert on the western fringe of a continent. You have a cold ocean current named the Canary Current, this time bringing cold water from the north down along the coast. As a result, you have the same phenomenon of upwelling, temperature inversion, and inhibited convection and precipitation. As with the Atacama and the Namib Desert, Hadley cell circulation results in a high pressure belt. Without belaboring the point, we see this same phenomenon again in Lower California and the Sonoran, where the cold California ocean current comes down along the coast and results in upwelling that increases stability in the lower air layers and reduces cloud formation and precipitation, resulting in an arid coastal desert. So what does this all mean? How do you map and incorporate coastal arid deserts into your world and your world building? First, look for areas around subtropical high pressure belts. Second, look for areas where cold ocean currents can displace warm waters through upwelling. Third, look for mountain ranges that can exacerbate the aridity by creating rain shadow effects. Now, I want to stress that a mountain range alone is generally not enough. The rain shadow effect is generally not enough to create an arid coastal desert. But the rain shadow effect can increase aridity where these other factors are present. Finally, as another possibly exacerbating factor, look for a continental effect, where the long distance between a source of moisture and the desert results in little or no moisture reaching the desert. So now we know why arid coastal deserts exist. We know how to place arid coastal deserts in your world. Next, let's discuss the implications of arid coastal deserts for your world building. Once you know the factors that create arid coastal deserts, the factors that exacerbate the aridity of arid coastal deserts, the creation and placement of arid coastal deserts in your world will become almost formulaic. But what is an arid coastal desert like, and how will that affect your world building? Let's start with access to water. If it's not coming down by a river, then you're probably going to need to rely on fog or drizzle. Although arid coastal deserts are hyperarid in some cases, they still experience fog and drizzle due to temperature inversion near the ocean surface. The fog can provide limited moisture for hardy plant species, or it could even serve as a source of water for human settlements by way of fog harvesting. The plant species that would dominate in these regions would be plants that are capable of surviving in salty soils, or plants that are capable and adapted to long periods without water. You might find sparse grasses, some cacti, and shrubs clustered in rare areas where groundwater is accessible or along fog-prone regions. You might also find some plants and animals that have adapted to extract water directly from the fog, like lichen-covered rocks in the Namib Desert that absorb moisture from the fog, and plants like the tillandsia and the Atacama that are entirely dependent on fog to survive. To the extent you find animals in arid coastal deserts, think small, likely nocturnal, something well adapted to minimizing water loss, like rodents, insects, and reptiles, with maybe a few larger herbivores or scavengers. For humans, water is going to be the most precious resource in these hyper-arid coastal desert environments, and that scarcity of water is going to shape everything. Now, in some real-world hyper-arid deserts, like we've discussed, communities have developed ways to harvest water from fog. They'll use things like fog nets to capture tiny droplets of moisture that can be funneled into storage containers. While rare, there are also maybe oases that could be fed by underground rivers or ancient aquifers that could serve as lifelines for nomadic groups and for permanent settlements. For more advanced societies, you might also see desalination, whether by some ancient or fantastical means that could provide another source of water. You might also, in a more advanced society, have solar or magical technologies that convert the seawater into drinkable water, providing a lifeline to desert cities. Thinking about the natural resources of an arid coastal desert, you're really zeroed in on three things. First, you have those offshore resources, right? That upwelling by the cold coastal currents. What does that provide? Well, it provides that nutrient-rich water. And from that nutrient-rich water, you're going to have an abundance of marine life. Second, and again, to the extent that humans are even around in these areas, you might see salt trade develop because of the number of salt flats that tend to surround arid coastal deserts. And finally, arid coastal deserts might be rich in minerals and metals. The Atacama Desert, for example, is known for its copper deposit. In your world, mining operations could extract valuable resources from the desert. Thanks for watching. If you like this video or just want to follow along as I develop the procedural map generator, hit like and subscribe below. Or leave a comment telling me about an arid coastal desert in your world.